The question reads, find the empirical molecular formula of a compound which contains 2 grams of carbon, 0.34 gram of hydrogen, and 2.67 grams of oxygen. The relative molecular mass of this compound is 60 gram per mole, and the molecular mass of carbon is 12, hydrogen 1, and oxygen 16. So the first thing we do, so let's solve. The first thing we do is to convert to mole. So we have carbon. To convert it, carbon will be, for carbon we'll have 2 all over 12, the mass of carbon, the gram divided by the mass of carbon, and so we're going to get 0.17. Then for hydrogen will be 0.34 grams, right? 0.34 will be divided by 16, no, by 1, so we're working for hydrogen. Okay, so we'll have 0.34, and then for oxygen we'll divide 2.67 divided by the mass of the oxygen over 16, and then we're going to get 0.17. So we are going to look at this. We're going to look at this, and we're going to divide each of these. The next step is dividing each of these with the smallest number, and the smallest here is 0.17. So if we divide each of that for carbon, if 0.17 is divided by 0.17, okay, so for carbon, if we divide 0.17 with 0.17, we'll have 1. For hydrogen, if we divide 0.17 by 0.17, we're going to 0.34 by 0.17, which is the smallest, we're going to get 2. And then for oxygen, we're going to divide 0.17 by the smallest, 0.17, we're going to get 1. Therefore, the empirical formula for this, so for the empirical formula is C, we have 1, and H, we have 2, so we go 2, and O, we have 1, so O. So this becomes the empirical formula for this compound that we're discussing about. So how do we solve for the molecular formula? Okay, so we're going to solve it on this side of the screen. Now we have the empirical formula, right? So we're going to take the mass of this empirical formula. Okay, so if the mass will be carbon, which is 12, okay, plus hydrogen, which is 2 here in our empirical formula. So we're going to have the mass, let's see, bracket C H2O. Let's call this entire mass, let's say X, all right, equals to our molecular mass of 60. So let's add 12. So we're going to add 12, carbon 12, okay, 12, then plus hydrogen is 1, so 1 times 2, because we have 2 hydrogen atoms in this formula, so we have 2, so 2 times 1 is 2, so we have 12 plus 2, that will give us 14, and then our oxygen is 16 plus the 14, that will give us 30, so we have 30 X equals to 60. So our X is equal to 60 over 30, and then we're going to get 2. Okay, so for our molecular formula, so we're going to multiply this factor 2 into this, because we have, for the molecular formula, we have CH2O. So we'll multiply 2 here, so our C, the molecular formula will be C2, right? Then in this place we have 4 hydrogen 2 times this 2 will give us 4. Okay, and then O2. Oh, 2 times. It's only 1 there, so we have O2. Giving us, this will be our molecular formula. If we want to rearrange this, we'll have an organic acid of this formula CH3 COOH. Okay, so we have 2 oxygen, 2 hydrogen, we have 4, 1 2 3 4, and then carbon we have 2 1 2. So this is how you solve molecular formula. Let's take another example where we're given the values in percentages. Okay, let's see. Okay, here it says find the empirical and molecular formula of a compound which contains 50.05% of sulfur and 49.95% of oxygen, and the relative molecular mass of this compound is 64.07 gram per mole, while the mass of sulfur we're going to use 32, and that of oxygen we're going to use 16. So we're going to assume first, for the empirical formula, we solve the empirical first. So we're going to assume that we're dealing with 100 grams of this compound, okay, because we're going to assume we're dealing with 100 grams of this compound. So for sulfur, 50.05, we're going to divide the percentages by their weight, their molecular mass, sorry. Okay, so if we have 100 grams, and 50.05% of 100 grams will be 50.05 grams, and 49.95% of 100 grams will be 49.95 grams. So our sulfur will be 50.05 grams, okay, while oxygen will be 49.95 grams. Okay, then we're going to convert it to moles. Sorry, we're going to convert these masses. This is gram. We're going to convert these masses to moles. Okay, so the next thing we do is, let's convert. So we're going to divide 50.05, just exactly how we did the previous one. Okay, all over 32, right? We're using 32 all over 32. So we're going to get 1.56. All right. Why? If we solve for that of this for sulfur, if we solve for that of oxygen, we're going to divide 49.95 and divide it by 16. We're going to get 3.12. Okay, so we're going to use the smallest, which is this, and divide it. We're going to use the smallest, which is this, and divide. This is our smallest, so we're going to divide both of these by the smallest. So if we divide 1.556 for sulfur, 1.56 divided by 1.56 will give us 1. While for oxygen, this divide by 1.56 will give us 2. So our empirical formula will be sulfur 1 and oxygen 2. So it will be SO2. Very simple. So we're going to compute the empirical weight. If we're going to compute the empirical weight, we have 2 oxygen here. We want to solve now for the molecular formula. So we're going to first compute the empirical weight. If this is 16 and we have 1 here, and this is 32, sulfur 32, and we have 1 here, and oxygen is 16 and we have 2. So if we solve that, it will be 32 plus 16 plus 16, right? So we're going to get a total of 64. So that becomes our empirical weight, right? Now already we're given the relative molecular mass of the compound to be 64. So we have, like we solved before, so we have SO2 X, right, equals to 64.07. So we've computed the empirical weight here is 64. So we have 64x equals to 64.07. So X is equals to 64.07 divided by 64. So we're going to get 1. So if we multiply this 1, so if our X is 1, right, so 1 multiplies goes into all this, so we have 1 times 1 sulfur, so our molecular formula will still be 1 sulfur, then 1 times 2 oxygens will be 2 SO2. So this still remains our molecular formula.